Hello, fifth graders. Today we are going to keep learning about water, and we are going to be studying an issue called scarcity of water. Now, a lot of you, when I've been reading your work, have identified a problem that you think the world might have, and that problem is that maybe there isn't enough fresh water. We have been really looking at how small the resource of water is, of fresh water, compared to salt water, how the accessible water, the water that we can actually get to quickly, like groundwater, lakes, and rivers, is actually a really, really small percent of the water that we find on Earth. A lot of the fresh water is trapped in glaciers, and then most of our water is actually salt water. And so a lot of you have been saying there might be a problem. Maybe people and animals and plants need more water than there is available. And we also looked a little bit at the water cycle, and you learned a lot about the water cycle in fourth grade. So you know that the water is getting constantly recycled. So even though we use water, that water goes right back into the water cycle, is purified through through evaporation and condensation and precipitation, and then we're able to use it again. But even though that is happening, there still is an issue about the amount of water, and that's what we're going to explore today. Scarcity means that there might not be enough, that it's scarce. There's not a lot of water or not enough water, and that's the idea we're going to look at. So getting started, last week we learned a lot about groundwater, and so start thinking right now, why do you think groundwater is so important? And how do you know, and how do you think the water is stored under the ground? So two things to think about. I'm guessing that you realize that groundwater is so important because that's really our biggest source of fresh water, and that's where most of us get our water from. Here in Rotterdam, that's where we get our water from, an aquifer. We looked at last week a little bit about how it's stored under the ground. And so groundwater, don't picture an underground lake. Like when you see this little diagram here, and we looked at some other pictures and videos last week, this is rocks and soil is here. It's just a big amount of water is also stored among those pieces of soil and pieces of rock. And so it's under the ground, but it's not just like an underground lake. So don't picture that. Picture that it's all filled with rocks and soil, but there's just a lot of water stored in those little spaces. Here's a video to help you understand if you're still not really getting it.
We all know the Earth is full of water, but there's a lot more to water than all that blue stuff you see on the globe. The water we can see on the surface of the Earth is surface water. Surface water is every lake, pond, river, stream, and ocean on Earth. But in the ground below your feet, there's even more water, groundwater. Groundwater is water that's crammed in the tiny gaps between rocks, soils, and sediments under the ground. A full body of groundwater is called an aquifer. There are huge aquifers all across America. The biggest is the High Plains Aquifer, which covers 174,000 square miles right in the middle of the country. Anything that big deserves a closer look. Let's say you could grab a shovel and dig straight down through the soils to an aquifer. The level underground where you first hit groundwater is called the water table. Below the water table, the ground is completely soaked or saturated with water, which is why this area is called the saturated zone. The area above the water table is called the unsaturated zone. So, how does all this water end up in the ground? Well, it's all a part of the good old water cycle. When it rains, some water gets soaked up by plants. Some water runs off the soil and into streams, lakes, or even the ocean. Other water gets stuck on the surface and eventually evaporates back into the air. Meanwhile, some of the lucky water droplets get to travel down through the surface deep underground until they reach the water table and become a part of an aquifer. Once water seeps down deep enough into the ground, it can stay there for a really long time. Some of the water stored in the deepest parts of aquifers has been there for thousands of years. But after it gets there, groundwater doesn't always stay in the ground. A lot of the water on the surface comes from aquifers. If the surface of the ground dips below the water table, groundwater flows out into the space, creating a body of surface water. If the surface water dries up, groundwater can flow in to fill it back up. And if the water table in this area rises, so does the level of the surface water. Groundwater can also pour down a sloping surface, creating streams. Any place where groundwater flows out into the surface is called a spring. Surface water can also become groundwater. If a body of surface water flows above the water table, water can seep down through the sediment and help fill the aquifer. Of course, there's another way that groundwater can leave the ground: us. Humans depend on groundwater, and there are thousands of wells all over the country that draw water out of aquifers. In many parts of the country, the water you get from the tap comes from the ground. However, we use most of our groundwater to help grow the food we eat. Farms can get lots of the water they need from rain, but rain isn't always enough. And in dry years, farmers depend even more on the water that's stored in the ground. In fact, American farms use about 53 billion gallons of groundwater every day. That's enough to fill over 1 million bathtubs or 80,000 Olympic-sized swimming pools. So, if we're using that much every day, can it run out? Well, yes and no. Remember, aquifers can be refilled by rainwater or surface water seeping in from rivers and streams. So there's usually more water on its way to replenish the aquifer. But if we use groundwater faster than the aquifers can refill, we could drain them dry. They probably wouldn't be empty forever, but it would take hundreds of years for the largest aquifers to get back to healthy levels. Whether it's up here or down there, water and how we use it matters. We may not be able to see it every day, but groundwater makes our lives possible. So don't let show-offs like rushing rivers and roaring oceans get all the attention. Those unseen aquifers below ground have been here longer than we have, and with a little love and care, they'll keep on taking care of us long into the future.
All right. I don't know about you, but I found that to be super interesting about groundwater. And really what today's lesson is about is taking care of those resources and making sure that we have enough water for our future. So this map here, I think I actually have a bigger version of it. That map shows different underground water groundwater sources. And so you can see that in some places where it's blue, like this dark blue color, that's where it's being replenished by the water cycle at a really, really good rate. And so this would indicate that there's plenty of groundwater in these areas. Now, as you go through, there's some different colors on this map, and you can see some places where, in these white areas, where it's kind of being replaced at the same rate it's being used. And so these areas would show places where the groundwater, the rain is replenishing it at about the same speed. But then as we get down into these yellow, orange, and red areas, those are places that show where groundwater is being used faster than it can be replenished by the water cycle. So let me say that again in case you're confused. When you look at this map, the areas that are these blues and greens colors, those show areas like here in Australia, up here in North America, here in South America, here in Africa. Those places show areas where the groundwater is being replenished or refilled faster than people are using it. So that would show areas where they probably have a really good amount of water and they're not experiencing water scarcity. Here in the middle, these places that are like this white and yellow colors, those show places where the groundwater areas are being refilled at pretty much the exact same speed that people are using the water. So it's kind of like a balanced equation. They're using just as much as being filled into the groundwater spaces. These are the areas of concern where there is red and orange. Those, like right here, this orange area down here in Florida, those are places where the people are using the groundwater faster than the groundwater can be replaced by the water cycle. And so those are some areas of concern, because you don't want to run out of water. Just like in the video, you don't want that aquifer to dry up, but they're pulling more water from the ground than can be replenished. And so those are areas that you really have to be careful. We all have to be careful, but those are areas that would be considered to be like at risk of running out of water for the scarcity water problem. So I have 2 more videos to show you about water scarcity and what happens when places run out of water. So let me share this with you.
Just sent me this solar wireless battery.
Oh, it was an ad, sorry.
I'm excited. Let's see what's inside. I really like the build.
All right, skip ad.
Say you're getting ready for a hike on a hot summer day. You're going into the woods far away from home and restaurants and movie theaters and malls and even other people. What's one super important thing you should definitely pack? Besides a compass or a map and hiking boots and the first aid kit and food and, okay, fine. There's a lot of stuff you should pack. But the most important thing? Water. Specifically, fresh water. After walking a lot in the heat, nothing will make you feel better than some ice-cold H2O. Why should you have to pack water, though? Can't you just sip some from a stream or river that you pass on your hike? Not necessarily. We've already talked about fresh water, so you know what it is, and that it's found in relatively small amounts on our planet. So, sadly, there's no guarantee that you'd stumble across any fresh water on your hike. But does the small amount of fresh water in our hydrosphere ever change? And what happens to plants and animals in the biosphere if the level of fresh water does change? Time for a little refresher. You'll remember that fresh water is water that doesn't contain a lot of salt in it. You'll also remember that for a planet with a lot of water on it, surprisingly little of it is fresh water. Let's review a few freaky freshwater facts. Most of the water on Earth is in the oceans. They're huge and also full of salt. In fact, about 97% of the water on the planet is salty. By contrast, fresh water is found in lakes, rivers, ponds, wetlands, and streams. Only about 3% of the planet's total water supply is fresh water. But about 2% is locked up in frozen glaciers or underground where we can't get to it. So that means of all the fresh water that's on Earth, less than 1% of it is actually accessible to us on the surface, and also to all the plants and animals we share that surface with. And different ecosystems have different amounts of fresh water in them. For instance, a rainforest will have a lot more than a desert, and that's okay because some ecosystems don't need as much as others do, but all ecosystems need some. So what happens to a single ecosystem when the amount of fresh water that's available in it changes? Let's take a look at one of the most important sources of water in the southwestern United States, the Colorado River. The Colorado River provides water to more than 40 million people in the states of Colorado, Utah, New Mexico, Arizona, Nevada, Wyoming, and California. People use it for farming, drinking, and growing their lawns, among other things. But there's a lot less water in the river these days than there used to be. Almost 100 years ago, in the 1920s, there used to be more than 22 trillion liters of water in the river. Today, there's about 4 trillion liters less than there used to be. What could explain such a large loss of water over a relatively short period of time? In a word, us. Humans are using more and more of the water every year, leaving less of it for future generations. This line graph shows just how much our dependence on the river has grown over the years. The blue line shows how much water is available, starting from the 1920s into the 2000s. It's mostly going down over the decades, except for a few upward spikes in especially wet years. This red line shows how much water we used each decade. This line has been going up, up, up until it's finally met the blue line on the right. Some people are worried that the demand for the river's water will keep surpassing the amount of water that's actually available. And to be honest, they should be worried. Less fresh water in a certain area doesn't just mean less water for the people that live there. It means less water for the plants and animals that live there too. The vaquita is a rare species of porpoise that lives in the Gulf of California at the end of the Colorado River. It's had to try to adapt to having much less fresh water in its ecosystem over the years, but it hasn't been doing so well. Today, there are fewer than 100 vaquitas left in the world. Vaquitas are just one kind of animal that live in or near the Colorado River. Thousands of other fish, birds, mammals, and other animals call the river home too. And if we take action now, we can keep it that way. When the availability of fresh water in an ecosystem, in this case the Colorado River, changes, it has a major impact on the humans and other animals that depend on it. Which brings us back to our big question. Can the already low levels of fresh water in our hydrosphere change? Yes, and when they do, it's not great news for the biosphere. That's why it's so important that we use less fresh water than is actually available in the world. Otherwise, one day, there will be less water than we need to survive. But there are lots of ways to keep that from happening, and luckily some super awesome humans have gotten together to keep our planet's freshwater levels from getting too out of balance. More on exactly what they're doing and how you can help next time.
Okay, so that might sound like bad news right now, but we are doing some things, and people do recognize this as a problem. I have one more video to show you just because I didn't want to leave it there, because there are some things we can do to protect our freshwater supply. And if some of you wrote to me on a couple weeks ago when I asked you that this is a complex problem, you are right. This is complicated, and this would be a great thing. We would be talking about this in school and having discussions. This would be a great thing for you to talk about with your parents. The one thing I will tell you, you don't want to save water by not drinking it. Humans need water, lots of water. So saving water by not drinking water is not a good solution. But being careful about the water you use when you shower or wash your dishes or do laundry, and not leaving the water running when you don't need to, not wasting water, those are good ways to protect our water supply. But make sure you keep drinking plenty of water. That's really important. All right, so what can we do to protect our freshwater sources? Let's watch this quick video and find out some things that people are already doing. Looks like we have another ad to do.
Popped over this wireless battery bank for an unboxing. Let's check this thing out and see what we got inside. This thing is...
I'm here to tell you not to panic. Just keep calm. If you watched the last episode, you might be a little worried because I told you that of all the fresh water on Earth, less than 1% of it is actually accessible to us on the surface. And we are using it like we've got an unlimited supply, which, you know, we don't. But even though humans are partly to blame for the freshwater problems on our planet, some of us are working on solutions to fix the damaged freshwater systems around the world. But how exactly have humans affected the amount of freshwater in the hydrosphere? And what are we doing to make things better? Well, I'm glad you asked. Last time, we took a look at the falling levels of freshwater in the Colorado River and the impact that had on local wildlife. So you know that freshwater levels can definitely change, but you might not know exactly what causes them to change. Probably the biggest thing that humans do that negatively affects the hydrosphere is overharvesting. Overharvesting is when people use too much water, like on farms or factories, or for personal use in their homes or offices. Basically, overharvesting is overuse. Pollution is another problem. When sewage or other waste from humans gets into the water, it can have a major impact on the animals that depend on it to survive. In some really bad cases, these animals can get sick or even die from living in contaminated water. Dams are the things that humans build built on rivers that can also reduce the level of fresh water. They're used to collect water from rivers so that it can be redirected to different places. But dams also keep rivers from running their full natural course. Cutting off the natural flow of a river can affect the quality of the water and also get in the way of the fish that migrate up and down rivers. Okay, now at this point you're probably thinking, come on Sabrina, get to the happier stuff. Well, there are ways to help conserve Earth's fresh water. Lots of them. But let's not just talk about how people are helping to protect our water supply. Let's actually see some results. We'll first visit a freshwater system that's bouncing back from some tough times thanks to some helpful humans. This is Elwha River in Olympic National Park in Washington State. It's looking good, right? Yeah, well, it didn't always look that way, though. A giant dam built nearly 100 years ago brought a lot of problems to the Elwha. All 5 species of native Pacific salmon live in this river, but the dam kept them from making their usual migration along the river every year. With less river space to call home, salmon numbers in the Elwha began to drop. Other fish were affected by the dam, too, because the water around the dam stayed in one place for longer than normal. The water got warmer than the fish were used to. This was a problem for 2 reasons. 1, most fish prefer to lay their eggs in cold water, and 2, warm water breeds parasites, which led to more disease in the fish, and which led to fewer fish as the years went on. So in 2011, some local people decided it was time for the dam to come down, and by early 2012, it was gone, and the work to fix the Elwha was underway. Since the dam has come down, almost 160 kilometers of habitat have been restored for the salmon species in the river. And today, the Elwha is looking awfully lovely. Plus, it's not the only river getting a new look. Since 1999, about 430 dams have been torn down across the United States, allowing rivers to return to their natural flows. Removing dams isn't the only thing humans are doing to pitch in. Groups have set aside some freshwater systems as protected areas to keep them from being polluted or over-harvested. And you can help by doing really simple things, like taking short showers or turning off the faucet when you brush your teeth. The Elwha still has a long way to go before it's fully restored, but if super cool humans keep pitching in, it might get there one day. So, while some humans in the biosphere do pollute and overharvest our fresh water, some are doing everything they can to protect the hydrosphere. What are you waiting for? Get out there and save some water.
All right, I hope you guys really loved this lesson about freshwater, because I do. I think it's so cool when we can talk and think about problems that we have and how we can come up with solutions to fix them. Today, you have no assignment. So when you are done watching these videos, you can mark this assignment as done. You do not need to turn anything in for science this week. If you would like to do an optional activity, because I know some of you really like to do fun things like this and are looking for things to do, you could make a poster or an advertisement to educate people on how to conserve or save water. You can use the ideas that you heard during this lesson, or maybe you have some of your own. You could make a poster, a video, a slide presentation, anything you want. You can send me a picture of it. You can share it with me. I would totally love to see it. The ways that you share things with me is you can use your Chromebook to take a video or a picture by allowing the camera, and you can upload that to your upload or download that to your Google Drive, and then you can share it with lsherman@mohonasen.org, or you can have your parents take a picture or a video and they can email it to me at lsherman@mohonasen.org. Actually, you guys can email too now. 5th graders have email. So those are different ways you can share things with me. And if you can't figure out how to do that, don't worry, it's okay. You can tell me about it. Send me a comment or an email and tell me what you did. That's totally awesome. I hope you guys have fun thinking, talking, maybe making something to start really thinking about what we can do to protect our water supply.